Peace be upon you all, my dear children. Today we are going to explore about the heat energy by observing this activity. When I am questioning on this activity, I give you time to check your answers. Then yourself you want to answer the questions. When I am answering, you can check whether you are right or wrong. According to this manner, our lesson will be progress. Okay, now you see these two setups. Are these two setups identical? Yeah, they are. These two setups are having same type of thermometers in same size, same beaker, equal amount of water, same candles. Okay, now observe the thermometer reading. Are they equal? Yeah, they are in equal reading. What is the reading? It's 25 degrees Celsius. Okay, then tell me what is the temperature of the atmosphere around these beakers? It is also 25 degrees Celsius. Then, what do you say about the temperature of these candles? They are also in the room temperature. So, all these setups are in the room temperature. Now, I am going to light this candle. Okay, now you can see there is a flame. Now, what do you say about the temperature of the flame? Is it higher than the water or less than the water? Definitely, it is higher than the water. Now, observe the thermometer reading. How is the reading? What happened to the temperature of the water? It is increasing. What is the reason for the temperature increasing of this water? You know, the kinetic energy of the water molecules increase. Energy, kinetic energy. How does this water gain this energy? From where this energy received? You know, the energy has transferred from this flame to water. Why this energy transfer from flame to water? Because there is a temperature difference between the flame and the water. The temperature of the flame is higher than the temperature of the water. So, energy flows from the object which is at a higher temperature to the object which is at the lower temperature. What is this type of energy? That is heat. Heat is the energy transferred from one object to another due to the temperature difference between them. Then, do you know the measuring unit of heat energy? Yeah. As the heat is a type of energy, it is measured by joules. At the same time, especially heat energy can be measured using calories. Here we have metal block at the temperature 60 degrees Celsius, water at the 25 degrees Celsius. Now we are going to put this metal block into the water. What will happen? We know the heat flows from the object at the high temperature to the object at the lower temperature. Then the metal block releases the heat while the water absorbs the heat. When releasing the heat, the temperature decreases. When absorbing the heat, the temperature of the water increases. After a while, the temperature of the metal block and the water become equal. After reaching the common temperature, heat does not flow from the metal block to water or water to metal block. This state is known as the thermal equilibrium. Here we have two beakers, same amount of liquids, different liquids, water, coconut oil, thermometer 25 degrees Celsius. Now we are going to heat this by the candles and we are going to observe the energy consumed by these different liquids to increase the temperature by 10 degrees Celsius. Okay, now we start to check the thermometers. Okay, now this coconut oil has reached 35 degrees Celsius. Now the water takes more energy. Okay, now the water is also reaching the 35 degrees Celsius. Now we off the flame. Okay, during this observation, what do you say about the amount of heat energy used to increase the temperature by 10 degrees Celsius? Yeah, we observe the energy required to increase the temperature by 10 degrees Celsius depending on the substance that the object is made of. The energy required to increase the temperature by 1 unit is also depending on the substance that the object is made of. The energy required to increase the temperature by 1 unit is known as the heat capacity. By this activity, we can conclude that the heat capacity is depending on the substance that the object is made of. Okay, now we are going to find out whether the heat capacity differ according to the mass in a same substance. Here we have taken the substance coconut oil in these two beakers. Here coconut oil, but in different masses. Okay, now start the heating. Okay, observe. Okay, less amount of coconut oil reaches the needed temperature. Okay, this coconut oil is still heating. Okay, this one also reaches the needed temperature. Okay, what can we conclude by this observation? Less coconut oil required less amount of heat. Much coconut oil required much amount of heat. So, the heat capacity depending on the mass of the substance. When doubling the mass, the required amount of heat also doubles. So, the heat capacity of a unit mass of a given substance is constant. That is called the specific heat capacity. According to the substance, the specific heat capacity differs. The specific heat capacity is depending on the substance. The specific heat capacity is given by simple C. The unit of specific heat capacity is given joules per kilogram per Kelvin, or joules per kilogram per degree Celsius. When giving the heat capacity, capital C, this heat capacity is depending on the mass and specific heat capacity. So, we can give this formula in C. Heat capacity is equal to mass into specific heat capacity. Now we have to understand how to calculate the amount of energy required to increase the temperature or decrease the temperature. So the amount of energy can be marked by this capital Q. We know the energy required to increase the temperature of 1 kg of a given substance by 1 degree Celsius. This 1 degree Celsius can be increase or decrease, whatever that is a change by 1 unit is known as the specific heat capacity. We mark the specific heat capacity by simple C. Then the energy required to increase the temperature of any mass of a given substance. So, the mass we mark by m, mkg, by the change 1 degree Celsius. If it is 1 kg, that is C. If it is mkg, that is mc. Now, the energy required to make a change in mkg by required amount of temperature change that can be given in theta. It is mc theta. Okay, using this formula, we can calculate the amount of energy absorbed or released when a temperature change takes place. So, we need the mass of the given substance and the specific heat capacity of the given substance and the temperature change. So this temperature change can be obtained final temperature by initial temperature T2 minus T1. If it is energy absorption, the T2, the final temperature is greater. Then we obtain a positive T. Then we can understand this matter has absorbed the energy. Sometime if the object release the energy, this T2 is lesser than T1. Then we obtain a minus temperature change. So, according to this, we can understand whether the energy absorbed or released. Okay, then we do some examples given in the textbooks. Open your textbook now. Okay, here we have given the question. Here we have asked to find out the energy. Find out the energy. This is our question. According to this, the M 6 kg. Specific heat capacity of copper is 400 joules kg minus 1 K minus 1. Theta temperature change is by 20 K. Now children, according to this specific heat capacity, this means the amount of energy required to increase the temperature of 1 kg of copper. 1 kg of copper by 1 K is 400 joules. Now, we have to find out the amount of energy required to increase the temperature of 6 kg by 1 K. Now our question is the energy required to increase the temperature of 6 kg of copper by 20 K. This is the question. So, we can get this 6 into 400 into 20. Then 48,000 joules. Okay. Here we have given the MC theta. We know the equation is MC theta. In this question, we have given all these MC and theta. So directly we can apply this to get the answer. Okay. In this question, directly we can apply the Q is MC theta. Here the M is 2 kg of water. C is 4,200 into temperature change by 10K. This will be 84,000 joules. Okay. This is the same as the previous one. Next, do some different questions. Okay, this is different question. Here the substance is aluminium block. Now, according to the question, the mass of the block is 500 gram. 500 gram. It should be changed to kg, then that is 0.5 kg. See, the specific heat capacity of aluminium is 900 joules kg minus 1 K minus 1. The temperature change. What's the temperature change? Yeah, they have set the temperature change as increase the temperature from 30 to 50. 30 to 50. Then what is the T2? 50. T1 30. Then the temperature change is 20K. Now apply the MC theta. Then 0.5 into 900 into 20. That is 2. Okay, children, according to this example, we'll do an activity from the exercise 9.2, question number 1. Here you have given the question. Specific heat capacity of iron is 460 kg minus 1 K minus 1. Find the quantity of energy to increase the temperature of 2 kg of iron at a temperature of 25 degrees Celsius. Okay, directly we can apply Q is MC theta for this question. Then we have to find out the quantity of heat energy. M has given, what is the M? 2 kg. What is the specific heat capacity of iron? It is given 400. Then what is the temperature change? Here they have given up to 65. So the temperature change is T2 minus T1. What's the T2 here? 65 minus 20. Then 2 into 450. Okay, make this more simpler. 460 into 80. Then 0, 8 times 6 is 48. 4 remains. 8 into 4, 32. Then 32 plus 4, that is 36 joules. These are very basic, simple questions. This type of questions occur in part 1 page. Okay. Now, let's do some different examples. Okay, children, read the question now. If 20,000 joule of heat transferred to 2 kg of copper at a temperature of 30 degrees Celsius, what is the final temperature? So, our question is the final temperature. We know theta. Here we have given this amount of heat energy transferred, mass of copper, and the specific heat capacity of copper also given. Then we can find out this theta. What is this theta? That is the temperature difference. This can be obtained by the final temperature minus initial temperature. Our question is this final temperature T2. This can be obtained by two methods. Okay, the method 1. Now we substitute all the data in this equation. So amount of heat given 20,000 joules. Mass of copper 2 kg. Specific heat capacity of copper is 400 joules kg minus 1 K minus 1. And the temperature change theta. This is the unknown temperature change. I bring this unknown to this side. Then bring this 20,000 to the other side. Down. This will be 20. So we got this theta, temperature difference is 25 degrees Celsius. Is it the answer? No. Then this is the temperature difference. When supplying this much of heat to this copper, that copper at 30 degrees Celsius increase by this 25 degrees Celsius. Then the final temperature is the initial temperature plus temperature difference. That is 55 degrees. Here we this answer add with the initial temperature. This T2 final temperature directly we can get by this method. The amount of heat supplied to copper is 20,000 joules. Mass of copper, specific heat capacity of copper. This theta, here we write like T2 minus, what is the T1? That is 30 degrees Celsius. Now, this unknown bring to this side. T2 minus 30. T2 minus 30 is equal to 25. Then this T2 25, this minus 30 bring to this side, then it becomes plus 30. Then the final temperature T2 is 55. When doing this method, you must remember to add this answer with the initial temperature. You want to continue this step also. But following this method, directly you can get this T2. Okay, according to this example, let's do an activity from exercise 9.2. Question number. Here read this question. Find the temperature of 8 kg of aluminium at a temperature of 30 degrees Celsius. When 14,400 joules of heat is transferred heat. The specific heat capacity of aluminium is 900 joules kg minus 1 K. Then children, what is the question? Find out the temperature of which temperature? Is it final temperature or the initial temperature? Yeah. According to the question, this aluminium is now at the temperature 30 degrees Celsius. When transferred 14,400 joules of heat energy, the temperature of aluminium rise up to the final temperature. Then the question is the final temperature. Okay, we understood what they have asked here. We can find out the theta. What is the amount of heat supplied to this aluminium? Yeah, joules. Mass of aluminium 0.8. Specific heat capacity of aluminium. We don't know the temperature change. Okay, we bring this theta to the side. Okay, then the temperature difference is 20. Then what is the initial temperature? That is given 30 degrees Celsius. So the final temperature is 30 and 20 is 50 degrees. Okay, here we found out the temperature difference. Then we add the temperature difference with the initial temperature. Then we put the final temperature. This is a method. The other method, this theta is T2 minus T1. Already we have learned this. This is the final temperature. We apply this directly to this formula. Okay, now we'll do the second method. Here, the quantity of heat energy supplied is equal to 0.3 into 900 minus. What is the initial temperature? T1 Okay. Now, unknown bring to T2 minus 30. Then, 5. Product of this 8 into 900. The product of 0.8 into 900 is 1. Now, T2 minus 30 30. Go to this side. It will become plus. Yes, here we have got directly the thing. Here the same answer, but quite different in the method. Okay, children. Now let's do some advanced examples. In this case, both the vessel and the water heats up. So we have to get the mass of the vessel 0.6 kg and the mass of water 1 kg. The initial temperature is 25 degrees Celsius and the final temperature is 100 degrees Celsius, as they have asked to increase the temperature up to boil the water. So that is the final temperature. So we can get the temperature different 75 degrees Celsius. If Cu plus Q water, MC theta for this. Mass of copper vessel is M 0.6 kg. C. Specific heat capacity of copper is 400 joules kg minus 1. M C theta. What is the temperature difference? The temperature difference is 75 degrees Celsius. What is this amount? 18,000 joules. Next, we calculate this one. We apply Q is MC theta for this water. The mass of water is 1 kg. What is the specific heat capacity of water? 4,200 joules. Kg minus 1, K minus 1. M, C. Theta. Theta is 75 degrees Celsius. Okay. Here I have written K minus 1. So, it can be K minus 1 or degrees C minus 1. Both are equal. I mark it K. Here also, I want to change this to K. The temperature differences are equal in Kelvin and Celsius. We have learned that earlier. Now, what is this? Joules. Now, total amount of energy required to increase the temperature of this system is joules. Okay, children. Now, according to this example, we'll do some activities. Here's the question number 3 from exercise 9.2. What is the question? The mass of a glass vessel is 500 grams. It contains 400 grams of water at 25 degrees Celsius. Here, the glass vessel and water. We have given the mass of glass. What is the mass of glass vessel? The mass of a glass vessel is 500 grams. Then 500 grams is 0.5. What is the specific heat capacity of the glass? 800. Now what is the mass of water? Is 0.4. What is the specific heat capacity of water? Is given 400 joules. It depends on K minus. In this case, we have to boil the water. When boiling the water, what is the final temperature? That is 100 Celsius. Now, when heating this water, the water and the vessel both heat. So, the heat has to supply to both substances. So, the total amount of heat energy has to supply is Q glass and Q water. Now we apply this. Q is equal to mc theta for this glass first. Then mass of glass 0.5. Specific heat capacity of glass 840. What is the theta? What is the temperature difference? We know the initial temperature is 25 degrees Celsius. The final temperature is 100 degrees Celsius. Then 100 minus 25 is 75 degrees. So the temperature change is 75 degrees. And the mass of water 0.4. Specific heat capacity of water 4200. Temperature difference. Here this 75 and 75 common. The total energy required to boil the water is 167,500.